A conductor carries a constant current of 16 amps, so I is 16 amps here. Assuming an electron charge of 1.60 times 10 to the power negative 19 coulomb, the number of electrons passing through a fixed point on the conductor every 1 second, in 1 second. Okay, so you know, these are charges. Electrons are negatively charged particles. They carry a charge which is equivalent to this. And we know from a very famous equation from physics that current equals to rate of flow of charge over time, right? Which is also to be written expressed as Q over T, where Q is the charge, rate of flow of charge, T is the time. And we know the Q has a unit of coulomb and time is S. And because this part is actually given in the question, 16 amps, so I can technically write it as 16 amps, or I can also write it down as 16 coulomb per second. The both units are pretty much same, right? Okay, now since our goal is to find out the total number of electrons, right, passing through a fixed point on the conductor in 1 second. So from this equation, I equals to Q over T. If I take Q to the left hand side of the equation, I get I over Q, and then I would be left with 1 over T. So I have rearrange this equation such that 1 over T equals to I over Q. And that is, this part right here is basically equivalent to number of electrons passing through a conductor in 1 second. Restoring the value of I, which is 16 amps, can also be written as 16 coulomb per second. One charge on electron carries a charge of 1.602 times 10 to the power negative 19 coulomb. This coulomb and this coulomb will cancel out. If you do the math, 16 divided by the denominator right here, you will get 9.98 times 10 to the power 19 electrons per second moving in a conductor. And that is your answer.